Now, the other set of questions in today's quiz has to do with a brick wall and how high can you make it. The original question in our textbook says this: brick has a density of 120 pounds per cubic foot. What is the maximum height of a brick wall if the allowable compressive stress is limited to 150 pounds per square inch, and the brick is 4 inches wide, and if the brick is 6 inches wide? So that's what his problem says. Let's break that down into pieces. First of all, I have drawn a cubic foot of brick here. 1 foot by 1 foot by 1 foot. That's a cubic foot. And it has 120 pounds of weight for that 1 cubic foot. So let me back up just a second, because what he is talking about here is that the brick has an allowable stress of 150 pounds per square inch. All right, so we're thinking about how much weight is at the bottom of a small 1 square inch. But he started out telling us about a whole cubic foot. So let's figure out how much that 1 square inch is. Let's start by thinking about how many square inches are there in a square foot. And how do we find that? 12 inches times 12 inches. There are 12 times 12 is 144. There are 144 square inches in a square foot. All right. Now, he tells us that the brick weighs 120 pounds per cubic foot, so this big old 1 foot chunk is 120 pounds. We want to find out how much this 144th of that thing weighs. And how would we do that? Well, now that we know there are 144 of those little square inches in a square foot, and they're 1 foot high, we can just say 120 pounds for this whole thing divided by 144 will tell us how many pounds in that 1 inch by 1 inch thing. And 120 divided by 144 is 0.833. All right, so how much does that little stick weigh? That little stick, 1 inch by 1 inch by 1 foot high, weighs 0.833 pound. All right, now we're getting somewhere. What are we trying to do? If the brick has an allowable stress of 150 pounds per square inch, how high can we make our brick wall without failing? How high does the brick wall have to be before we reach the limit of 150? So we just figured out that 1 inch by 1 inch by 1 foot high stick weighs 0.833 pound. So if a column is 1 foot high, it weighs 0.833. How much does a column weigh if it's 2 feet high? Well, it must weigh twice that much, right? If 1 foot is 0.833, 2 feet must be 2 times that much, whatever that is, 1.666, I think. How much does a column weigh if it is 3 feet high? Well, it must be 3 times that much, right? 3 times 0.833. So we're working our way up. How high does that 1 inch stick have to be in order for it to weigh 150 pounds? How are we going to do that? Let's see. So we're thinking about, here's our 1 inch by 1 inch stick, 1 foot high, 2 feet high, 3 feet high. How high do we have to stack it in order to reach 150 pounds? If each one of these little 1 inch by 1 foot sticks weighs 0.833, so it's 0.833 pounds per foot, we can say 150 divided by 0.833 to find out how many feet. Pounds over pounds cancel out, and we are left with feet. 150 divided by 0.833 equals how many feet? I think you will find that you come out with 180 feet. So that's just a massively high brick wall. You could stack up this brick wall 180 feet high before the thing would start to crumble at the bottom. That's pretty high. Now, the next question is, what difference does it make if the bricks are 6 inches wide instead of the standard 4 inches wide? So here's our 1 inch by 1 inch stick, a foot high. So there's 1 square inch at the bottom of that thing. What if we put another 1 square inch next to it? What if we put another 1 square inch next to it? How much does each 1 square inch thing weigh? It still weighs the same 0.833 pounds at the bottom of each one of those 1 inch sticks. So does it matter how many of those little sticks we put next to each other? No, it doesn't. We're just focused on how much is at the bottom of 1 square inch. And so this question that he asks, how high can you stack the wall if you make the brick 6 inches wide, is a bit of a red herring. Well, not a red herring. Our textbook author is trying to get us to think about the fact that it makes no difference at all how wide we make our wall, because we're always just focused on 1 square inch at a time.